Greetings, friends. This is Sunday, April 26th, not long after Earth Day. I was at the coast, at the Oregon coast. There's a lot of Cascadian history, which I could go into because that's actually topical here on this channel. What we do here is take what I call a place-based approach to education, which is replicable. It's like, oh, well, you can do that because you live in Cascadia, but that's not how it works. Obviously, it's like you are the center of your own coordinate system. Like wherever you are, that's your center. You know how everyone seems a little smaller than you physically because you're closest to you? Like your eyes are right in your head, so you're like real up close to yourself. Like if you put your thumb towards your eye, your thumb can be bigger than Mount Everest, can't it? So in that sort of what coordinate system is that where whoever is looking is the giant? That's sort of an interesting geometry, isn't it? I'm not sure it's what we call XYZ, but with that segue, I want to go into a somewhat philosophy of mathematics mode. Having been digging through my very wonderful Wittgenstein collection on loan from Alex, talked about him, I believe, friend of the physics teacher, or actually his mother was the student, sixth grade student of the physics teacher who worked with me on first person physics. That's another thread here. You can also call it roller coaster physics or nosediving in an airplane physics. I don't know. In the Bucky stuff and synergetics, which is a thread we follow here very much, there's kind of an implied dogfight. You know how Infinite Jest, hard book to read, kind of compared with James Joyce sometimes. It's lucid and yet hard to make it cohere, and people spend a life, seems like, teasing out what's in it, and synergetics is kind of like that. And there's this constant referring back to airplanes in flight and their propeller planes. I always think of Snoopy pretending to be the Red Baron, right? Or fighting the Red Baron, right? That was it. Or was he the Red Baron? Anyway, Snoopy on the top of his doghouse, you know, this cartoon character. And I'm just talking about the propeller metaphors. He talks around about frequency and the gun that's mounted on the front of the fuselage and it goes right through the propellers. Doesn't shoot off the propellers unless your timing is off, and then you shoot off your own propeller. And that's kind of, in a way, dark humor in a way. It's kind of noir that you would shoot off your own propeller in the middle of a dogfight. It's like, what would the other pilot think if you did that? Anyway, I just wanted to bring up the propeller action because I think propeller action is core to synergetics, central in synergetics, and right at the heart of the tetrahedron, we have these six vanes, as I call them, VANES, reminds us of windmills and stuff. And those are the isosceles triangles with a common center, the center of the tetrahedron. And each one of these vanes is just any two quadrays, we call them, any two vectors, any two edges from that tetrahedron's, regular tetrahedron center to any two corners, right? And there are six ways to do that. And that gets you the six vanes, and they have specific angles, specific edges. And that's where I bring the quadrays in, the Quadray Coordinate system in Wikipedia. And my philosophy of math deal, what I wanted to just say here and then pretty much close off, or for this video, that is, do we want to call this inside linear algebra, these quadrays? Because do they need an inner product? And it's like the first impulse of a lot of people, especially from the XYZ side, is first of all to start with cube coordinates as things like 1, 0, 0, 0, 1, 0, negative, this kind of ones and zeros, maybe negative numbers and all. Make it symmetric around the origin at least. But make the cube have those nice coordinates, and then the quadrays are going to be with respect to that, because we want to map the quadrays to the same space the XYZ maps. IVM and XYZ tie together by means of quadrays. But if you don't use the idea of vanes to do it, and you're not starting with the D-edged tetrahedron vis-a-vis the IVM ball of diameter D, radius R, then you're not going to get the distance that I get between the origin and any of those 4 points, which is second root of 6 over 4. So I'm seeing a lot of Quadray's implementations, which is gratifying. It's like the namespaces are proliferating that incorporate the Quadray coordinates as something a little bit different. You might see them called simplicial coordinates. It's a little bit new the way we're doing it. But then when I say we, I have to part company, and then I'm sticking to my specific application, which is to explicate synergetics and in particular the volumes table. So I want my A module to be 1/124th, to be 1/24th of the regular tetrahedron, and so on, and to have the edges that match what's in the published book, figure-wise, in terms of what that distance is from 0, to, say, 1, 0. What is that distance, that magnitude? For me, it's clearly second root of 6 over 4. And others have made it different because of how they do they stretch the tetrahedron to the XYZ in a different way. They come up with a different answer. Some people want to privilege one of the spokes of the caltrop and say that's the vertical spoke and therefore corresponds to Z in the XYZ coordinate system. That's trying to colonize the IVM with XYZ thinking, really. And I'm not into that in particular. I prefer not to privilege the Z-axis in any particular way. I don't privilege any of the XYZ axes, nor do I privilege the whole system, the whole caltrop-based system, as being inside of linear algebra, because there's no dot product necessarily. And if you do talk about dotting in the usual way, any two quadrays, and you get 0 as the answer, does it mean they're perpendicular or orthogonal? Well, that's the whole idea of linear independence and linear algebra, is mutual orthogonality in however many dimensions. And you want an inner product of 0 to signify mutually independent, which means mutually orthogonal. And it seems that whole language game is foundationally different from what we're doing. It's like already a fork. So going back to primitive meanings, the beginnings, the philosophies of mathematics that I'm into, let's just start and posit that Quadray coordinates are not inside of linear algebra because there is no dot product. But then you'll see implementations of quadrays everywhere that do include it and basically are basted in, rolled in 4D of Hilbert space, right? They're not even aware necessarily of the 4D of the Bucky subculture. Like they've lost touch with where quadrays were coming from for some of us. So they're eager to make it sound like Hilbert space all over again. Whereas I'm saying, hold on, maybe this isn't even linear algebra, just a family resemblance. Wittgenstein, you must have studied Wittgenstein. Yes, that's exactly right. That's why I want to keep my implementation aloof from just another Hilbert space denizen. It's something outside, and we can use it to explicate another namespace where 4D means something different than in Hilbert space. That's what I'm interested in, and the volumes table. So far, none of the other Quadrays implementations that I've seen to date are following those same plot lines. They have a different narrative. Maybe they're just looking for some intellectual property or something more conventional, right? Something where they can use AI to make it sound more like everyday sort of, I'll call it Hilbert math or Conway math or Coxeter math. We're talking 3 namespaces as usual, because it's not Einstein either. Anyway, that was fun, and that was where I wanted to leave it today. Place-based, Earth Day, and Amy Goodman. saw her in person. She didn't see me. I was just one more person in the audience. But if you know Democracy Now, I've got a review. I'll put a link because we're playing World Game here, and she's a World Game player par excellence. She plays it differently. I'm not comparing us, but I do show how we overlap in my review because I had a similar set of foci as she did in many ways. Okay, talk to you in the near future. Bye-bye.